Alright guys, we're going to walk you through condenser fan motoring, troubleshooting, and replacing of a condenser fan motor. So there's a few things that can go wrong if you notice that your condenser fan motor is not spinning. It could be you don't have the proper voltage, the capacitor could be bad, or the motor itself could be bad. And we're going to go ahead and walk through those components, those things, and see what is wrong with this condenser fan motor here, because this one here wasn't spinning. So the first thing you want to do is here I'm shutting off the power on the disconnect there, that little box right there to the left, and we're going to take some readings. So what you'll want to do is trace the wires that go to your condenser fan motor. You'll have two hot wires and a capacitor fan wire, so they're typically 3 wires. So just go ahead and trace those, find out where they are, and the 2 hots are usually on the contactor. And what I'm doing here is just cutting the tie strap so I can better trace my wires and so I can get ready to remove them. So one of the things here that we'll go ahead and test is see if we have proper voltage. That's one of the first things you want to do. So go ahead and turn that switch back on so that we can test the voltage. And you're going to test it at the top of the contactor. And you set your meter to volts so you can take the voltage readings. And then what I'm going to do is manually push in the contactor with my finger. Now be careful if you do that. But that's just the way for me to start it, just like that. And I have the 241 volts. So I do have proper voltage going through the contactor to the motor, but it's still not spinning. So the next thing you want to do is go ahead and check the capacitor, because like I said, it could be either the contactor is not sending the voltage, capacitor could be bad, or it's the motor itself. So I take off the fan and the common wires off the capacitor. The common is coming from one side of your contactor, and then the fan is on the fan side of your capacitor. And this one was rated at 5 microfarads. So we're going to want to see somewhere around 5. If we don't, then the capacitor is bad. You need to replace it. But if you do have that capacitance, which is right now 4.8, which is definitely enough to turn that motor, so that tells me the capacitor is good. So the contactor is good. Send the proper voltage. The capacitor is good. So those 2 items are good. So now what's left is checking the motor itself. So what I did is spin the top of the fan blade, the top of the motor, and as you can see, it is not spinning very easy. Once you spin that thing, it should just keep spinning and spinning. So there was no need for me to go to the motor leads to take measurements, because that motor is seized up with the bearing. So I already knew right then and there that motor was bad. But here later in the video, we're going to show you how to take readings, electrical readings of the motor, to see if it's bad, see if it's open, grounded, shorted, things like that. Because yeah, you won't always have seized bearings. There's going to be an electrical problem with the motor. But those are the steps. Check for voltage, check your capacitor, and then move on to the motor itself. And we're going to cover that contactor in a video here, if we already haven't, to show you how to test the contactor to make sure that's good, because that's what sends the power to the compressor and the fan motor. So here we're just going to go ahead and take it apart. That conduit is just to keep the wires from drooping down, hitting the fan. That conduit can be a little tight, so you just got to work with it to get it out of there, wiggle it out of there. And I've already got my wires disconnected. So what we got to do is find a way, see how tight that fan motor, that fan blade was. And be careful when working with this, when you're removing it, moving it around. Please do not bend that propeller, that fan motor, or the fan blade, that is. And then just pull the conduit off. You got your wires there. Now we're ready to remove the fan blade. Now that's got a short shaft on it, which is flush with the hub. If it's long, I usually take some sandcloth and sand down the shaft, and then I oil it up with WD-40, and that makes it a lot easier to remove, so you're not sitting there fighting with it. And then on the hub there, you've got that screw, that bolt that you'll loosen up, and then what you'll do is grab the shaft under the propeller blade. Here I thought I might be able to kind of get it with the adjustable wrench, which I wasn't, so just go ahead and grab a pair of pliers, grab a hold of that shaft, and then you can wiggle that blade. And just remember to work with the center of the blade there while you're removing it, so you don't bend the propeller blades. And then just pull that right off of there. And then we're gonna, I already ordered the motor for this. It was the supposedly the exact replacement. However, this air conditioner is 12 years old, so sometimes they do change things around. And right there I'm just marking where my wires come out so I can make sure I position the motor in the right place again. But this motor was being held on by screws, so I'm just taking the screws out. The replacement motor, which is from the manufacturer, is mounted differently, and you'll see that here in just a second. So everything is not always the same. That's just something you're gonna have to work with when you're doing repairs on these air conditioners. So just go ahead and take those off of there. And I've got it fast forwarded to just get rid of the boring stuff. So as you can see, it's not very difficult, just a few screws. And like I said, I already ordered the replacement motor. And a lot of times the motors will come with mounting nuts themselves. Sometimes they won't. So you may have to go to a hardware store and buy the mounting nuts if it doesn't come with one. Universal motors, they usually do. However, these OEM motors, sometimes they don't. But just take that out of there, and you're going to see that this is also a 3-wire. You got 2 hot leads and 1 lead for your capacitor and your grounding lead right there. That's the green wire. So as you can see, there's studs coming out of there on the bottom instead of screws. And luckily, you know, I always carry the nuts. Like I said, sometimes they come with them. That's what I'm looking for, to see if it came with any mounting nuts, which it didn't. But I always carry them because I run into this all the time. So get yourself those the proper size, and then now we're good, ready to remount that. And just put your wires, you know, where your mark was, so that the wires are kind of facing the right way, the right direction. And yeah, sometimes when you're putting it all back together, an extra set of hands would be handy, but you can do it with one person. Just takes a little playing with. So we'll start putting those mounting nuts on there. And when you got them all on there, there's no need to really torque down on them. Just put them nice and tight and snug. You know, you don't want to overdo it. You can end up snapping one of those studs. And obviously we don't want to do that. But if you have a deep well socket set, makes it a little easier to get it in the tighten. I have it in my van, but I also had this with me, the wrench there, so I just decided to use that. And once we get all those tightened, we're going to go ahead and put that fan blade back on. And again, you're going to want to position that fan blade where it was on the old motor. So you're going to want to get it as close as possible to where it was. You can use a tape measure to take a measurement. I do remember that this was mounted flush, so I just was mounting that one flush because it was the same size, same length of shaft. But yeah, it is important that that motor be in the spot that the old one was, or else you're going to make the air movement, the amount of air, the CFM, you're going to make that difference if you have a long shaft and you position it lower than it should be. So here we can see the motor is spinning, the blade is spinning real nice and free. So we're going to go ahead and put that conduit back on, and that's kind of a pain in the butt. You got to feed the wires through it. Sometimes you have a hard time, moving them through that conduit. But the way you took it off is just the way you put it right back together. You don't have to change anything. Just remember the steps. Also the wiring. You can put tape or something on the wires to remember where they go, or take a picture. But yeah, you do want the wires to go where they came from. And again, you'll have two hot and one fan motor lead, or fan capacitor lead. So again, be careful when you're putting it all back together. When you're taking it apart, you don't want to bend that propeller. You don't want to bend that, or else it's going to vibrate the whole condenser if it's off balance. And then put all your screws back on. And as you can see, the conduit's back in there, and that's just keeping the motors from sagging and hitting that fan blade. So I'm going to go ahead and try to fast forward through this boring mounting stuff. And when we're done with that, we're going to go ahead and hook the wires back up. But first, we're going to replace that capacitor. If you're replacing the motor, a blower motor on the furnace, a condenser fan motor on the AC, it's always good practice just to replace the capacitor with it. This way you don't have to go back, in a few months, a year, whenever it goes out. This way you have a nice new motor, nice new fresh capacitor, and shouldn't have to mess with it again for a while. Now on a dual run capacitor, if you get a new one, you'll have to get the size that is matched for the compressor. So I think this one was a 40 microfarad for the compressor and a 5 for the fan motor. Now the fan motor can even come with a different size. Instead of 5, the fan motor may be 7.5, in which case you're going to have to get a capacitor that's 7.5 microfarads. So just keep an eye on that. So if you get a dual, get a 40 plus a 7.5. Whatever your compressor is rated at, whatever your motor is rated at, get that proper capacitor. And we're getting that mounted in. We'll hook up our wires. And on the capacitor, it'll have there's 3 posts. A C for common, which comes from one side of your contactor. You'll have one that's labeled Herm. That's for your compressor. And then the third one is labeled fan, and that's for your condenser fan motor. So you got to make sure that they're all put on the right post. Again, if you have to label them, go ahead and do that. You can write down on a piece of paper what the colors were and where they went to, whatever you have to do to get those wires in the proper posts. So once I got these wires connected, that's when we're going to go ahead and test it out. And what I'm going to do now is just take a tie strap and just tie the wires together, make it nice and neat, so then the wires aren't hanging out like spaghetti. Just makes it look a lot better. And I'm going to go ahead and turn the power back on. And again, I'm going to manually push in on the contactor. Again, be careful when you do that. And as you can see, the motor spins. And right now it doesn't look like it's spinning very fast, but it actually is. It's just the effect of the camera, I guess. So you test it, make sure it goes the proper way, the proper direction, and that'll be that. Okay, we're going to cover a universal motor here. You can buy universal instead of an OEM. They're a little more difficult to install, but they're a little bit cheaper. And you can find these online. If you wanted to get an OEM motor, which is the exact same motor that comes out of your condenser, then you can always go online, just type in the model number of condenser, and you'll come up with parts for it and the condenser fan motor. But this one here, universal, covers different applications. Now when you're replacing a motor, you always want to make sure that the data is all the same on your, from your original motor. So you want the horsepower to be the same, the RPM, you want that to be the same voltage, 208, 230 volt, and the same amperage. This one here is 1.3 to 1.4. So all those have to be the same to match your existing motor. And also the capacitor. This one's a 5.0. Make sure that you got the right capacitor. This one's reversible. The rotation is reversible, so you can make it turn one way or the other. The rotation is at the lead end. This is the lead. These are the leads. So this is the lead end. So when you're looking at it from the lead end, this would be counterclockwise, this would be clockwise. Some of them are rated from the shaft end, so you would look at the shaft end, and that would be clockwise, counterclockwise. But this one is reversible with these purple and yellow wires here. So if this one's set up right now, yellow to yellow, purple to purple, that's for counterclockwise. If you wanted to go clockwise, you would just take one of the purples, put it to the yellow, and the other yellow to the other purple, and that will change the rotation on there for you. And these universals sometimes will come with a long shaft like this. Your regular standard OEM motors might have a shorter shaft, but you're going to want to position that fan blade exactly where it was on the original motor. So if you have to, you can take a tape measure to measure from the motor to where the bolt is to mount the mounting bolt for the fan blade. Doesn't have to be exact, but it's got to be really close. And then the other side is your mounting studs. These ones are relatively short. Some of them will get to be quite long, and you can just leave them sticking up, or after you mount the motor, you can take your pliers and just break these off, and that'll give you a flush mount. Now let's take some resistance readings to tell whether your motor is good or bad. And you can do this on your original motor, and you'll set your meter here. You can set it to ohms. This one here, above it, is ohms with the beeping sound. I like to use that one. So take your black and white, and on some motors it'll be black and red. Same thing. It doesn't matter. So you'll put one on one wire, another lead on the other wire, and you'll get 30 ohms. So that tells you the windings inside are good. Now if you have these connected on both wires and you get that OL, that means your windings are open and the motor is bad. So you need to get resistance. Now the resistance you get will depend on the size of the motor. This one's a 1/4 horsepower. If you get up to a 1 horsepower, which is a pretty big motor, you'll get more resistance because there's more windings in the motor. And then you want to check your motor for grounds. So you take your 2 power leads, put a lead on one, and then the other one to the case of the motor, and you should get OL. You should not get any readings whatsoever. If you do, then your motor is grounded, and if it's grounded, it's probably going to pop your breaker for the condenser. And then the same thing with your compressor. If that's grounded, it's going to pop the breaker. But we're going to cover the compressor here in a bit after, in a later video. But that's how you check your motor. And this one is a 4-wire. So you got the 2 hot wires, and then you got the 2 brown wires, which are for your capacitor. You can use a its own individual capacitor with these two wires. Now, again, most condensers will have one capacitor for the motor and the compressor. It's called a dual capacitor. If you want to use it as in the dual capacitor application, then you can just omit the brown wire with the white stripe. Just do away with that, and that will turn it into your 3-wire, 2 hot legs, and then the brown one to your capacitor, the fan side of your capacitor, and that'll turn it into a 3-wire for you. So I just wanted to cover a universal motor, how to take readings of your old motor, see if its windings are open or grounded. Now, one last thing, take the 2 wires, and if you're getting 0, so again, when we did this, we were getting I think it was 30 ohms. Now, if you're getting 0 ohms, then that motor is shorted. It's just a direct short. So you'll either have 0, which is a direct short, you'll have 30, depending on the size of your motor, which tells it's good. If you get this OL, the windings are open, motor's bad. So that's how you kind of read your motor, test it electrically. And the last thing is, you can have bad bearings on your motor to where this shaft will not spin, or it's very hard to spin. And again, in that case, you need a new motor. So just wanted to cover the OEM motor for you if you decide to get one of those. We'll see you on the next video.